to tie a tie. Wait, no, don't record yet.
Andy's Basics! Yay!
In this episode, we'll be talking about
ocean acidification.
Hi, my name is Professor Andy, and I'm a professor named Andy.
Hi, Professor Andy.
Okay, class, today we're gonna learn about ocean acidification, which is the acidification of the ocean.
Wow, I can't wait to learn from you, Professor Andy. No wonder why you have so many students.
So you see, class, for many years the concentration of carbon dioxide in the atmosphere has increased due to the burning of fossil fuels and land use change. The ocean absorbs about 30% of the CO2 that is released into the atmosphere, and as levels of atmospheric CO2 increase, so do the levels in the ocean.
What happens when CO2 gets absorbed by the seawater?
When CO2 is absorbed by seawater, a series of chemical reactions occur, resulting in the increased concentration of hydrogen ions. This graph shows the rising levels of carbon dioxide in the atmosphere, rising CO2 levels in the ocean, and decreasing pH in the water off the coast of Hawaii. As seen in this graph, as atmospheric CO2 increases, the partial pressure of CO2 of the seawater increases as well, and the seawater's pH decreases. This increase causes the seawater to become more acidic and cause carbon ions to be less abundant. Carbon ions are an important building block of structures such as seashells and coral skeletons, starfish, and all the other animals. A decrease in carbonate ions can make building and maintaining shells of other calcium carbonate structures difficult for calcifying organisms, such as oysters, clams, sea urchins, shallow water corals, deep sea corals, and calcareous plankton. These changes in ocean chemistry can affect the behavior of non-calcified organisms as well, creating a domino effect that ruins the hydrosphere. Certain fish's ability to detect predators is decreased in more acidic waters. When these organisms are at risk, the entire food web/biosphere may also be at risk.
Wait, Professor, I have a question. How would you explain this on a molecular level?
Well, you see, if you stop cutting me off, then I can have time to explain to you.
Sorry.
Shut up. Anyways, as I was saying, on the molecular level, carbon dioxide combines with water and carbonate ion to produce two bicarbonate ions. With this, the consumption of carbonate ions impedes calcification. This kills animals and coral reefs, which causes the geosphere to become more unstable by the loosening of the ground.
Oh!
So in conclusion, ocean acidification is a very serious problem. They can affect us through the Earth systems in many negative ways, especially the Earth's ecosystems and the wildlife that lives in these ecosystems.
Oh, so how does it affect us?
Oh, I'm so glad you asked. I can't believe I almost forgot. So you see, humans are linked to the health of the ocean. We have always relied on the ocean's resources for food, recreation, transportation, and medicines. One of the most obvious connections people have with the ocean is seafood. Most of the shellfish we catch are going to be negatively impacted by ocean acidification due to the fact that they will be able to build sturdy shells. Some oyster hatcheries in the Pacific Northwest have already been impacted, and we have seen declines in larval settlement and survival rates. Pteropods may seem insignificant to many people, but since they're a major food source for fish, their survival is very important to us as well, since we eat fish and fish can't survive without them.
But Professor Andy, how can we help in decreasing ocean acidification?
Don't make me send you to the hallway, young man. Let me finish my darn lecture. So anyways, in 2013, carbon dioxide in the atmosphere passed 400 parts per million, higher than at any time in the last 1 million years. The safe level of carbon dioxide is around 350 parts per million, a milestone which was passed in 1988. Without ocean absorption, our atmospheric carbon dioxide would be even higher, closer to 475 parts per billion. The most realistic way to lower this number, or to keep it from getting astronomically higher, would be to reduce our carbon emissions by burning less fossil fuels and finding more carbon sinks. If we did do those over hundreds or thousands of years, carbon dioxide in the atmosphere and ocean would stabilize again. Even if we stop emitting all carbon right now, ocean acidification would not end immediately. This is because there is a lag between changing our emissions and when we start to feel the effects. It's kind of like making a short stop while driving a car. Even if you slam the brakes, the car will still move for tens or hundreds of feet before coming to a halt. The same thing happens with emissions, but instead of stopping a moving vehicle, the climate will continue to change. The atmosphere will continue to warm and the ocean will continue to acidify. Carbon dioxide typically lasts in the atmosphere for hundreds of years. In the ocean, this effect is amplified further as more acidic ocean waters mix with deep water over a cycle that also lasts hundreds of years.
You must die!
Go in the hallway.
How could this happen to me? I made my mistakes, got nowhere to run. The night goes on as I'm fading away.
Every day, little Gorons are being abused. Please support us by giving us an A on this project.
What happens when CO2 gets out? So basically many I can't do this, guys! Wait, Professor, I have a question. How would you explain this on a